Okay, so as a reminder, we're going to go ahead and write down what our rays are as we go along, because we put them on the other side and we don't want to keep flipping our page over. Okay, so we're going to find our center of curvature. So this one is, our focal point's about 2.8 centimeters. So we're going to go 2.8 centimeters on the other side, and you should be slightly off the line. That's where your center of curvature should be. Okay, so don't worry about, is it going to go up or is it going to go down? You're going to line up your center of curvature with the top of your object and go to the mirror. So there's our dot for our center of curvature. There's the dot for there's the top of the object, and we're going to go to the mirror. In and out through the center of curvature. Our next light ray is going to go in parallel, out through the focal point. So from the object, we're going to go in parallel, and then, so we're going to go in parallel. The more careful you are when you do this, the better your ray diagrams will come out. So we're going to go in parallel, and then from where it hits the mirror, we're going to go out through the focal point. So make sure you go through the middle of the focal point. Okay, now we have a problem. Remember before all those light rays met up on this side? Do you see our light rays aren't meeting up? Okay, that tells us that we have to bring the reflected ray. So let's make a note. Bring the reflected, the out ray behind the mirror. So the in rays stop when they hit the mirror. That's an R. The in rays, but the out rays appear to have come from inside the mirror. So we're going to bring that back dotted. Let's go ahead and make a note, dotted. We have to do that with the first one also. And they're meeting up here. So our third light ray, we're going to go in through the focal point, and we're going to go out parallel. So we're going to line the object up with the focal point, in through the focal point, and we're going to go up and hit the mirror. And then from there, we're going to go out parallel. That looks pretty parallel. And then we're going to bring that back dotted too. Only the out ray gets brought back dotted. So we went in through the focal point, stop when you hit the mirror, go out parallel. And see, they're all meeting up right here. So that's where our image is going to be. Okay, so last one. In through the vertex. And your angle of incidence is going to equal your angle of reflection. So this is the one you need to use your protractor for. And for this one, some of you are going to have to like add a piece of paper back here and extend your ray, because you're not going to be able to measure the angle because it's some of your ruler or your protractors are too big. That's okay. They still work. So I'm going to bring it all the way back here so that I can measure it. So I see how I started it way back here. And will I be able to measure it with this protractor? I will. Yay! Okay, so I lined up my spot with the vertex, and I lined up my 90 degrees with my principal axis. Now watch how I'm going to count the angle. 10, 20, 30. This is like 34 degrees. 34 degrees. Okay, so we're going to measure 34 degrees on the other side. 10, 20, 30, 34 degrees. We'll make a little mark. Label as 34 degrees. Okay, as long as you get like within 2 degrees of my angle measurements, you're fine. And then we will come out. We're going to line up the vertex with where we made our mark. Zoom. And then we will bring that back behind the mirror. And we're going to connect our principal axis with where they met up. And there's our image. So everything behind the mirror is dotted because it's not really there. You had to force it to be there. Those are going to be dotted. Dotted light rays. Because they're not really there. You had to force it. Remember, you had to force it because they wouldn't meet up. It's forced. Okay, so how do we describe this image? It's upright. And since it's upright, it is virtual, because remember, virtual and upright go together. Plus, it's in the mirror. Okay, a real image gets, here's where we would put the screen. But this is in the mirror. A virtual image is in the mirror. And it is also magnified. Because if we look at the length of this arrow and the length of this arrow, this one's sizably bigger. 2 more to go. You're getting it.